send you the right? I mean, did any of you go through it? Did any of you go through the implementation part? Okay, whatever it is, I mean, just go through. Okay, and another one thing I wanted to make sure that I don't think that you will be getting recordings of these. Okay, already they have uploaded the YouTube, right? They have sent you an YouTube link where they just had taught the classes. Did you go through anyone went through that YouTube thing? Did any of you go through that YouTube? Yeah, that YouTube channel which was created. Someone at, I think Kanika ma'am had shared it to the group. Shall yes or no?
Yes, ma'am.
Okay. So I mean, did you go through all the YouTube links in which the sir had taught? I mean, there will be some 7 classes, right? Like, I mean, I didn't go, I mean, I didn't check what he have done, but I just saw the timings like 2 hours, and also, I mean, maybe he would have clubbed 2 or 3 classes together and he would have finished the portions. So I mean, if you haven't checked, just I think sorry, yeah, if someone want to tell something. Okay, so if you haven't checked, please try to check. Okay, because this project, I mean, as much as you are new, I am new for this too. So I am not sure, I mean, from where you will be working on the projects. Okay, so just go through the YouTube links, and also I think in classroom also he have shared something. Okay, just go through that also. So because, and then let me know, I think only this week will be there. So I have taken, I don't know how he had taken classes. So now if regression, I have taken some algorithm. For classification, I have taken some algorithms. Next is clustering, I would be taking one algorithm. Okay, so like that I'm going on. So now I don't know whether he have included any other algorithms. So you just please, I'm not getting time to check all those YouTube. So thing. So please try to check and tell me if there is any algorithm I have to teach. I mean, in this week itself, you have to tell me. Okay, did you get it what I'm saying? Someone take the responsibility to check the YouTube. Yeah? Can someone check the YouTube and let me know? Nobody is ready to check the YouTube. Am I audible? Am I audible?
Yes, ma'am.
Okay. Can anyone check the YouTube channels? I mean, it's like it's for your thing, or it's not actually for my sake, but I'm not getting the time to go through it. So can anyone check and tell me what all the algorithms he had covered? I mean, it's not like that in today itself you have to do this. 1 week is there. So before this Saturday, you have to let me know. Anyone can take the responsibility? Anyone willing? Yeah. Anybody can do that? And did you check in the classroom? Did you share anything in the classroom? Any PDF files? Not getting any response from you people. Okay, so if possible, I'll be checking the YouTube. I don't think it's possible, but this is the maximum I'll try to check what all the algorithms he had covered. So, but I mean, if otherwise, please you to try check the algorithms. Okay, mostly everything will be based on how what he had taught. I think the project or whatever it they are going to conduct will be based on what he had taught in the YouTube. That is why they are not taking any recordings of what I am teaching or Angit sir teaching. So that is like I think maybe the last batch or something Tejas sir would have taught, and that recordings they are keeping for future references, I guess. Did you get it?
Yes, ma'am.
Yeah. Why are you so dull, all of you? I mean, I'm not getting any responses from you people. All of you are very, very tired. Okay, so these sessions are going to end. So, like before this week end, right? Before the Saturday, try to. I mean, almost all the things we have covered. The main things are what you will be having is the regression classification in the supervised, and then in the unsupervised clustering. That's the main thing you have. Then it goes for the deep learning, where you'll be having artificial neural network, AN, and all these things. Okay, so that will be like you will be having an overall view about all those things. So these are the main part. The thing is that you have to try it on yourself. I mean, by on your own. Then only you will get to know what it is. Okay, so otherwise it's like now it will be like quite easier, but when you do the project you will get all sorts of doubts. Okay, so that's why I'm trying to every time I'm telling you go implement in the Python and see whether you're getting the answers, all these things. So here these are all like worked examples I'm just giving for you as an example. Okay, so but when you work and see that you will be getting so many, you will be able to find out so many flaws over there. Sometimes the error will be there, so the error will be like what's like a simple semicolon, or some issues will be like that. So when you work on Python you will actually know, okay, so what it is, why the error is coming, all these things. And actual working, only when you work you will find out the actual working, what is happening inside the algorithms. All this you will be knowing when you are working. So try to work. Okay, so anyways you will be asked for the project, so I'm not sure what will be the project, how they'll be asking, whether they will ask me to give the data set or you will be implementing anything. I mean, we have learned about all these things, right? Linear, logistic, KNN. So maybe it would be like any one of the algorithm you have to take, and you have to find out a data set and you have to implement and show. Might be that is a project. So if it is like that, it would be very easier. But I just saw this some question paper, like, or some quiz or something in the classroom. So I don't know for what it is there. So if there is some quiz or something, then it will be like based on what he have taught. So that is why I'm going on asking, like, you have to just check the YouTube channels. You have to just check in the YouTube channels, and so that you'll be able to do if there is some quiz or something, because I don't know whether I'm covering everything what he have taught in the YouTube channel. So because for me the syllabus is given according to the syllabus I'm going. So it's not like that one, it's not like that classification contains only this much. There are so many algorithms out there. Okay, so many algorithms are there, so I'm just selecting some and I'm just explaining. So that's why I'm keeping on telling you to check it. Okay, so to the maximum try to check it. Okay, so anyways, we had some nice holidays because of so many festivals. So okay, I'll just give the quick view of decision tree. So now decision tree comes under the supervised learning, and it can do both regression and classification problems. Okay, and then here this decision tree representation, you will have this leaf nodes, root nodes. Okay, leaf nodes, root nodes, or the common terminologies you will be having. And then here the main thing you will be using here is information gain. Okay, this information theory is anyone remember what is the information theory? Okay, it's the quantification of the information. It's a way we measure the information is information theory. Information theory is a subject where we learn about how we measure the information. Okay, so for the measurements, we have the entropy and then information gain and gain ratio. And another one I'll introduce today is the Gini. Okay, so Gini index or Gini ratio is another one. measure. Okay, so these are the main measures. So now here this entropy is a measure of disorder. Okay, so entropy is a measure of disorder. This you have to remember. So here entropy, the formula for entropy is summation of all the probabilities and the logarithm of all the probabilities and the log to the base 2 logarithm of all probabilities. That is the entropy formula. So now coming to the information gain, that when you reduce the entropy from the whole, you will be getting the gain. That's the information you are getting. That is, you are just reducing all the disorder. Now this gain ratio will be the information gain by the intrinsic information. So the intrinsic information is the entropy of data sub data set proportions, or you can say it as some randomly selected sample is put into. Okay, I like the quantification of that randomly selected data, or okay, where you are put into, I mean how you are put into that quantification. It's a measure that which you are selecting, that measure, why you are selecting that measure, it will be the intrinsic information. Okay, so that is all this. So now here this you would have, I mean you would have gone through, I guess. So there are decision nodes, chance nodes, end nodes. So this again we can call it as leaf nodes, roots nodes, all these things. Okay, so all you guys remember all those things, right? So decision node we have to put it in square, chance node in round, circle, and end nodes. Okay, end nodes in triangles. So this is a usual way of representing. So sometimes there will be most of the time, I mean when if you check it in Google, there won't be like boxes and all. Okay, so there won't be boxes, there won't be any could you guys are seeing the PPT, right? Or you
Yes, ma'am.
PPT? Okay. Okay, so now when you check in the Google about the decision trees, in most cases they are not using the I mean procedure like square for decision node, circle for chance node, and then end nodes to be represented by triangles. All this they don't use it. So directly what they do is they will just give the decision. Here the condition will be given, and then they will just have the branches, and then you'll be having the leaf nodes. Okay, chance node is like very rarely you'll be having the chance nodes. Mostly it will be like the main like the root node and then the leaf nodes. Getting my point, right? And so there won't be like anything like wherever you search, there won't be like this thing, there it won't be done properly. But in your quiz or in interviews, there is a chance of asking, so what, how will you represent all this? That's why we are going through all these things. Okay, so that's root nodes and leaf nodes. Or this tree can't be built without the root nodes and leaf nodes. Okay, so now the leaf nodes can be like going on, so many leaf nodes can be done. So this these internally the final leaf between the final leaf nodes and the root nodes, the nodes which we call it as internal nodes. Okay, so this can be of any number of internal nodes will be there. So next is the splitting. Okay, that's when the branch is splitting from the root node or any node into subnodes, we call it as splitting. And pruning is what? When the decision tree grows very complex. Okay, when it is like going to overfitting, we have to cut it off. Like some branches. So in order to, as we do gardening, we will cut it off when it goes like to the other compound, or when it is not producing the fruits or flowers. So those branches we cut it, right? So here also those branches we'll be cutting off. That is called as pruning. Okay, so we saw this example, like whether a person is hungry or not. If it is yes, then he's checking whether it's midday or not. If it is midday, then he is going to eat lunch. If it is not the midday, then it's like it's evening, right? So when if it is evening means it is after 6 p.m. or not. So now if it is after 6 p.m., he'll have the dinner, and if it is not 6 p.m., he's going to have a snack. So this tree is all about what to do when he is hungry. So that is the question. Okay, so that he have to decide he is hungry and what he have to do. So the rest of the things here in this, the work to do, have you worked out, all these are not necessary. So that is where we have to cut all this part. Okay, so that by that way we will be eradicating the overfitting. Okay, so that it won't be complicated. Okay, so directly this will be the actual tree. Okay, so this is how you have to work out. So the main problem in decision tree is what you will find it is to find out this root node, this first the problem statement, to find it out, to from where to start. That will be the main problem for you guys. Okay, so now for the implementation, so here this is one example. Okay, this is an example of a data set for so this is like a comedy shows or some comedian going. Okay, and the age. Okay, so age is given for the person, experience is given, and the rank is given, and the nationality is given. So here it's whether he will go or not. Okay, this will be given whether he is going to it or not. So now here we have how many data is here. Someone like how many samples are here? Someone count and tell me. Anyone please count how you are able to see this, right? You are able to see the presentation, right? I'm just trying to find out whether you are understanding something or not. Just count the number of samples here.
13.
Yeah. So here 13 samples are there. So in 13, how many persons will go or how many persons won't go? Or I'll say how many no's are there and how many S's are there?
7 years and yes,
7 S and
6 no.
okay. So here 7x and 6 no is there. Okay. So now here we have to here we are implementing. So this is a very simple program implemented. That's why I had taken this. Okay. So but when you are doing the problems, when you do the real world problems, it won't be as simple as that. You have thousands of confusions. And here it, because why? Because the mainly is the thing is that the features will be, so many features will be there. So here how many features are there?
4.
Yeah, here 4 features are there. Yeah, right. So similarly, so there will be so many features will be given, and there will be some like thousands and thousands of samples will be given. So that is why it will become very tedious. So try to take as simple as like this or more simple, like 5 samples you can take and try to work it out. Okay. So now here you have, so here in this for the tree, you will be importing some new library. Okay. So this is import py.plus plus is for this tree itself. And also in most of this other algorithms, we saw this import matplotlib. Okay. But here we will be importing. Okay. That is for the plot. Only for the graph, we are imported the matplotlib. And here we'll be importing the matplotlib.image. Okay, why we are importing it? Not because the tree is considered as an image, right? So in order to show that, we will be importing the matplotlib.image also. So from matplotlib. So this matplotlib is a library. Okay, so from that we usually take pyplot, and here we are taking the image also. Okay, and then here this scikit-learn.tree is for this tree, this decision tree classifier. We are using this. Okay, so here other than that, you will be having pandas. You can import pandas, you can import numby, all these things. Okay, so now here and here in this example, usually in all the examples, import pandas as PD will be given. So here in this example, they didn't take it as PD. So here when you come into the reading part, when you want to read the data, here it is given as df is equal to pandas dot. Directly they have taken it as pandas. Okay, So don't confuse that. As PD also you can take. Why we are taking as PD? Because instead of writing pandas, PD is very simple for me, right? I will write as PD itself. So that is why I take usually as PD. Okay. So now here df is equal to pandas dot read CSV, and here I mean that whatever the data set you have to take, that data set you have to put. Okay, so the next thing is here, this here all the everything is in numbers, so no problem. Age, experience, rank, all these are in numbers, so no problem about it. But this nationality, so here this nationality is in this characters, right? So this I have to convert it as number integers. So this conversion part I am doing it over here. So I'm giving UK 0, USA 1 and 2. Okay, so UK, USA, you would be knowing, and I'm not sure what they're mentioning. Maybe it will be like New York or Netherlands, whatever it is. Okay, just consider this is another nation. Okay, and is another nation. Okay, so now this nationality, this now we are mapping this nationality, like, so this df of nationality is equal to df of nationality dot map d. So now this is a data frame, because in the data frame df I had taken, I have read already the shows. Okay, so that I am mapping with this d. Okay, so this d, so I now I will get this UK, USA and this another nation I'll be getting in terms of numbers or integers. Okay, so now next is similarly when I see this yes and no, there also it is of character, so again I have to map it with numbers. So that also I'll be mapping it with numbers. Okay, I'll just transform it into numbers. So here I have the features: age, experience, rank, nationality. Okay, I have the 4 features as age, experience, rank, nationality. So now what I am taking now, x and y. X is my independent and y is my dependent variable. So x is all the features, that is the df of features, and y is the that what we are going to find, what the decision we have to make or something like that. Okay, so that is go. So now here, this D tree is any name. Okay, the decision tree is equal to decision tree classifier. This decision tree classifier, same as linear regression and everything we did. This is the term, okay, used to call the classifier. Okay, this classifier is in the this in the library scikit-learn. Okay, so you have to take it from there, and now I am calling it. Now what I am doing, I am fitting my variables in this decision tree. Okay, in this thing I am just fitting my x and y. Okay, and now here I am exporting this to graphviz. Okay, so graphviz is another one library where you will be, it's used for the transformation of graph visualization. So that is the tree visualization you have to transform. Okay, so now this d tree, then outline feature names, features. Okay, now here next is graph pi dot plus. The pi dot plus also from the, for the tree we have to use this, only then you will be getting the data in the tree. So we are using this pi dot plus. Okay, now then we are writing as a png. The png, you would have heard what is png, you all know what is png, right? png, jpeg, everybody would be knowing, right? All these are the various forms of images: png, jpeg, all these things, bmp. Okay, so here we are taking it as png. Okay, so here we will be getting the data in the decision tree in the form of png. I'll be sending a link. Okay, so for this particular thing you have the explanation for each and everything. Okay, so just go through that link for the program alone, because this decision tree is quite, I mean, whatever, like other compared to the other algorithms, this is quite difficult, but still you have to understand a little more, because this similar thing will be used in the random forest. Okay, so random forest, if there is time I'll be taking, but that is like similar to decision trees. Okay, so try to understand. I mean, I'll be sharing the link after the class. Just go through it. There will be a detailed explanation of this programming part alone. Okay, so go through it and then you try to implement it. Okay, so only then you will be able to know. Okay, so now here image, I mean, I'm reading the image and I'm plotting the image. Okay, so now from here I'm reading the image and then I am showing the image so that the tree I'll be getting. Okay, so here in this decision tree classifier we are using, so I have already told you, right? So there will be uh, entropy, information gain, gain ratio. For what we are using all these things? Entropy. Anyone remember information gain, gain ratio? Why do we use all these things? Anyone remember which we took in the last class? Why should we calculate this entropy or information or gain ratio? Someone try it out. Even if it is wrong, it's not a problem. Just try it out. What did you understand from last class? Why are we taking this information gain or gain ratio, entropy? For what we are doing all these things? Anyone, please? Just try, no?
And gain ratio helps in modification of the data set after the splitting.
Yeah,
If it's
for the splitting. Okay, so it's for the splitting we are actually taking this. Okay, so sometimes we split based on the entropy itself. Sometimes we split based on the information gain. Sometimes we split based on the gain ratio, and sometimes it will be this Gini. So here all this, because in Python as it is like all these libraries and everything was inbuilt, so here it is taking this Gini. Okay, so this Gini method it is taking. So in when you take this Gini method, I mean here actually the formula will be like 1 minus summation of pi square itself. So here I same here, like information is like 1 minus entropy, right? Okay, so here entropy is summation of pi log to pi. Okay, so here in Gini actually more, I mean the formula as its symbol, the basic formula will be 1 minus same like summation pi square, that is the probability square you will be getting. Okay, so that here for this particular problem, because they are considering only this particular problem, they are giving it as 1 minus x by n the whole square minus y by n the whole square. This again x by n and y by n are the probabilities. So here they are taken the x as the number of positive answers and y they have taken as number of negative answers or the no. X will be your yes response and Y will be your no response. Okay, that's how they had taken it. So here also they are finding out 1 minus probability square. Okay, so here for this particular problem, they have used particularly x by n and y by n because they just wanted to explain over here. Okay, all of you getting what's a formula, right? 1 minus summation pi square, that is 1 minus sum of 1 minus sum of square of all probabilities. Getting the formula, right? That is a basic formula. Here in order to show you how it is done, they have given us x by n and y by n. So here all the things, when you go in deep and when you go in the Google and check, for everything there will be a basic formula, and for everything there will be like different sets of formulas will be given. Okay, so don't confuse that everything will be the same. Okay, so when you do the mathematical processing and everything, so we will be getting at the end result there will be a different formula, but the basic formula will be same. Okay, so even for the linear regression, the basic formula is y is equal to mx plus b. But then when you go through, when you check in the Google, it will be like theta on x, beta on x, all these things. But then from the basic thing, they would have derived. Okay, so the basic formula will be same for everything. So try to come always from the basic. So go to the simplest formula first. Take the simplest formula and then try to find all these things. Okay, so here the probability. So now that is why I asked from this in the starting itself the total number of samples. So now when you see here, here the totally 13 samples are there. So you know what is the probability, right? So probability is the number of favorable outcomes by total number of outcomes. So here x is number of the favorable outcome for me in x is the number of positive answers. That is number of s. So we already saw from here, right? So here we already counted the number of s. The number of s is 7. So here they have written it as 7. 1 minus 7, and the total number of outcomes or total number of samples is the 13. So 1 minus 7 by 13 the whole square. And similarly my y over here is 6, right? So here that is y is no. The number of no is 6. So here I am taking 6 by 13 the whole square. Okay, so here 1 minus 7 by 13 the whole square minus 6 by 13 the whole square. So I get my value as 0.49. Okay, so you just calculate, it will be around 0.49 or 0.5. Okay, so you'll be getting the value as 0.5. Okay, around 0.5 you will be getting. Got it? So this I'm taking as my thing for finding out the first thing. Okay, the first thing I am taking the number of s and number of no's, and then I am finding out the Gini index. I am getting 0.49. So I think one. Okay, mostly I mean wait a second. Were you able to see this screen?
Yes, ma'am.
Okay, so here I am taking my rank. The main problem for the decision tree is to find out the first root node. Okay, and then you have to each and everything you have to check. So first I am checking for my rank. Okay, so this rank will be, that is rank is less than 6.5. Okay, so how many are there in less than 6.5? In this rank, how many are there in less than 6.5?
5.
Sorry,
Total
how many?
5.
Yeah, 5. Totally 5 are there, right? So in this 5, how many no's are there and how many s is there?
All 5 are more.
All 5 are no's. Now someone calculate for me the Gini and tell me the answer. Someone calculate for this. Now you have 0 yes and 5 no's, right? So someone the Gini for me and tell me.
One minus 5 by 13 whole square.
No, here remember, here what is there? Here our root node is less than 6.5. So less than 6.5 we have only 5. So the number of samples, that is total, we will be having only 5. So now tell me.
1.
Yeah, perfectly. You're right. So 1 minus 1, that will be 0. So whenever this Gini comes 0, we will stop that condition and go for the next one. Okay. So now here we got it as 0. So remember, when you have all the set, I mean, if there is no samples, all the samples having same values, then you will be having 0 as the Gini index. Okay. So you can stop with that condition. So you can stop that condition and go for the next thing. So now here it happens to be true. That's so you get the Gini as 0 in the samples file. So you can stop this condition. Now if it is not true, okay, so then go for the next condition. Next condition they are taking as nationality, and next they will check the Gini, and then next they will be checking the age. So then they will be taking the experience. So so whenever 0 comes, okay, so whenever you get 0, you will stop that condition and you will be going for the next one. Okay, that is how this decision trees goes. Okay, so finally when you end it up, everything, you will be like final, you will end it up with the 0. Okay, so you won't go, you will be able to go further. Getting my point? Okay, so when you find out the Gini as 0, you will be stopping that condition, and then you will go for the next condition. So now first in the rank I got 0, so I stopped my rank condition, I went for the next condition. So next I will go for the nationality, then I'll go for the experience, then I'll go for the age. So similarly I'll be going for the next conditions till I find a proper solution, till everything gets 0. Okay, and another thing is that, so it won't be as easy as that. The first thing, it is like the root node or the order of the thing, if to find it out, it will be very difficult. So here they are for in, because it's already given for us, so it was easy. Okay, first itself the rank was given. So otherwise you will be taking each and everything, you will be finding out, and then you will be producing a decision tree. So that is how this order first to which to take, all this will be the major problem. So now I think in the name bias also, like we had so many conditions, right? Like humidity, like weather, outcast, all these things. So the first which weather to take. Okay, so or first which part we'll be taking, all these will be of condition, all these things will be confusing. Okay, so we will be always doing the hit and trial method. You will be doing trial methods, or you'll be finding out the entropy. So which one is having the major entropy? Okay, so that you will be finding out, and then you, depending upon the entropy values, you will be taking as a root node. Okay, so now if the entropy is less in the rank, so I'll be taking the rank as the root node. So depending upon that, you can take a root node, and then you can do the further classification, further splitting. Okay, so this is how you will be doing it. Okay, so did you get some idea about this decision tree?
Yes.
Okay, so this you try it out. Okay, so today you try it out, this decision tree. I mean, I'll be sharing this link for that. Okay, so this same, the very same example for each and everything with the full explanation, it will be given. So just go through that and try it out in Python. Okay, implement it and see. Okay, so because I'm thinking every day you're not doing any of the tasks, so just try to implement and check it out. Okay, so anything else you want to ask? Okay, so just go and try it out. It would be like you will be having so many doubts if you try it out. Okay, so after that you can just mail me, or you can just post it in the classroom itself. Okay, what you have done, you can post it out. If you have doubts, you can mail me. Okay, just try to do it, try to implement it. Maybe like even if it is not like this data set, you can take the much smaller data set. Okay, and then you can try it out. Okay, getting my point? Okay, so that's it for today. I have already shared the full PPT with you. Okay, I mean the last class itself. I mean when sir was taking, it was like last Friday when he took. It was like unexpected, right? So and then Thursday itself, somebody was asking me. Not Thursday. So Thursday, Friday, you had holidays, no? It's like Tuesday itself, someone was asking me for the PPT. So I shared it in the group itself. The group itself. This PPT completely I have shared. Sure. So PPT, you can go through it, and the link again, anyways, I'll show for the step-by-step procedure. Okay, the step-by-step procedure in the sense for this each and every splitting, right? So they had given the explanation for each and every splitting what's coming. Okay, so now you have to remember one thing: it's for anything to stop, any leaves to stop. I will be having zero as Gini. So then only I can stop it. Okay, so usually when I'll get zero is when I get all the samples the same thing. So here I got it as all the samples as same, right? I think S or something. So similarly, in those conditions, I'll be getting zero. Okay, so just go through that link also and try with the same data set and the different data set as well. Okay, and please somebody if just check in the classroom whether he shared any PDF or anything. So if he has shared something, then just go through that. And this YouTube also try to go through it. Okay, so I mean mostly I'm covering I mean more than what is there in the YouTube. But still, if there is something else, so you shouldn't miss out. Okay, so that's why I'm going on telling the you to check the YouTube also. So if you could check, it will be better. Okay, so okay, we'll see tomorrow. Thank you.
Thank you.
Thank you, ma'am.
Yeah, thank you. Bye. Take care.
Thank you, ma'am.
Thank you.